We are going to see the definitions of Fourier transform, Fourier sine transform and the Fourier cosine transform. Fourier transform for the function f of x is denoted by capital F of x. Fourier transform to the function f of x is denoted by capital F of x, and it is defined as Fourier transform of f of x. How to read this symbol means Fourier transform of f of x equal to integral minus infinity to infinity e power isx f of x dx. Fourier transform of f of x is also denoted with the symbol capital F of s. This is Fourier transform to the function f of x. The Fourier inverse transform. The Fourier inverse transform is denoted by this is a Fourier transform. Inverse Fourier transform means f inverse of f of s, and is given by 1 by 2 pi integral minus infinity to infinity e power minus isx f of s ds. If we shift f to another side, f inverse f of s, inverse Fourier transform, it is also given by f of x. This is inverse Fourier transform to the function f of s. Next definition is Fourier sine transform. Fourier sine transform. Fourier sine transform. Fourier sine transform to the function f of x is denoted by Fourier transform of the function f of x means this one. In particular, we are writing Fourier sine transform. Just that's why I denote in suffix s. So it is equal to 1 by root 2 pi Fourier sine transform is denoted by capital F of x in suffix s is defined as integral 0 to infinity sine sx f of x dx. This is Fourier sine transform to the function f of x. Fourier transform means we denote like this, but it is Fourier sine transform. Now the inverse Fourier sine transform is denoted by Fourier sine transform, this one. Inverse Fourier sine transform is denoted like this, and it is defined as Fourier transform means integral minus infinity to infinity. That's why inverse Fourier transform also we got minus infinity to infinity, but one constant we got 1 by 2 pi. In the same way, inverse Fourier sine transform we will get 2 by pi integral 0 to infinity sine sx Fourier sine transform ds. It is also given by f of x. These are Fourier sine transform, inverse Fourier sine transform. Next one is Fourier cosine transform. Fourier cosine transform is denoted by like this, and is given by integral 0 to infinity cos sx f of x dx. It is also denoted by fc of s. Inverse Fourier cosine transform is denoted by equal to 2 by pi integral 0 to infinity cos sx Fourier cosine transform ds. It is also equal to f of x. In some textbooks, in the Fourier transform definition, here you will get one constant extra, that is 1 by root 2 pi. You will get one constant extra here. Accordingly, you will get 1 by root 2 pi in the Fourier sine and cosine transforms. But no need to bother about that. We are following Agrawal textbook. In this BS Agrawal only we are observing these definitions. It's enough if you remember these definitions for Fourier transform, inverse Fourier transform, Fourier sine transform, inverse Fourier sine transform, Fourier cosine transform, and this is for inverse Fourier cosine transform.